This video introduces the concept of a rational expression with definitions and examples. When learning new definitions, it is often helpful to review similar, familiar terms. We begin with the notion of a rational number. Recall that a rational number is a number that can be expressed as a ratio of integers. Some examples include 2/3, -1/5, 7, which can be written as 7/1, and 0/2, which equals 0. A fraction with a 0 in the numerator equals 0, and a fraction with a 0 in the denominator is undefined. It seems likely that a rational expression will also be a ratio of special expressions. In fact, a rational expression is an expression that can be written as the ratio of polynomials. Some examples include 1/x, 3/4, the expression with 3x minus 6 in the numerator and x squared minus 4 in the denominator, and x squared minus 5x minus 6 over the quantity 2x squared plus x minus 3. Since the denominator of any fraction cannot equal 0, we have some restrictions on the domain of a rational expression. In general, the domain of an expression is the set of all values that can be substituted for the variable in the expression. The values of the variable that make the denominator of a rational expression 0 are called the restricted values for the expression. To find the domain of a rational expression, set the denominator equal to 0, solve for the variable, and disallow any restricted values found. Some examples might help to clarify this process. The domain of 1/x is all x not equal to 0. Sometimes factoring the denominator is necessary to determine the restricted values. In the second example, when we factor the denominator x squared minus 4 as x minus 2 times x plus 2, the restricted values become clear, and the domain is all x except plus and minus 2. Similarly, in our third example, it is hard to discern the restricted domain values until we factor the denominator. Then we can see that the domain is all x except -3/2 and 1. To simplify rational expressions, the process is to factor and cancel. Recall that to simplify a fraction of the form a times b over a times c, we cancel the common factor of a and get b over c. This is the same process we use to simplify rational expressions. To simplify 3x minus 6 over x squared minus 4, we factor the numerator and the denominator to get 3 times x minus 2 over the product x minus 2, x plus 2. Then the common factor of x minus 2 cancels, leaving 3 over the quantity x plus 2. Of course, we still have the restriction that x cannot be plus or minus 2. In particular, we must specify that x cannot equal 2, since we've canceled that restriction in our algebraic work. To simplify the expression x squared plus 5x minus 6 over 2x squared plus x minus 3, we again factor the numerator and factor the denominator. We then can cancel the common factor of x minus 1, leaving x plus 6 over 2x plus 3. Again, we need to specify that x cannot equal -3/2 or 1. In particular, x not equaling 1 is essential to state since we made that restriction invisible with our cancellation. We include additional examples for extra practice, but the process is the same. To simplify a rational expression, we factor both the numerator and the denominator, and then cancel any common factors. Of course, we also want to explicitly state any restrictions that apply, paying particular attention to any restriction that we made invisible by our cancellation. It might be helpful at this point to review factoring polynomials from earlier videos if the factoring step is giving you difficulty. Once the numerator and denominator are completely factored, cancel any common factors on top and bottom, and then state any needed restrictions. One last time, we factor the numerator and denominator, cancel any common factors on top and bottom, and explicitly state any required restrictions.